A 100,000-ton warship longer than 3 football fields just floated for the first time in years. The USS Gerald R. Ford, America's most advanced and expensive aircraft carrier ever built, has completed critical repairs that took 15 months inside one of the world's largest dry docks. This $13 billion floating fortress is now being rolled out, ready to dominate the seas once again. The engineering feat to move this colossal vessel is nothing short of extraordinary. What went wrong that forced this supercarrier into emergency repairs? And what makes this ship so crucial that the Navy couldn't afford to lose it? Stay with us. The USS Gerald R. Ford isn't just another ship. It's the first of an entirely new generation of American supercarriers designed to project unmatched power across the globe. When this vessel entered dry dock for extensive repairs, it marked a critical moment for the United States Navy. The Ford-class carriers are equipped with revolutionary technology that no other nation possesses. Electromagnetic catapults, advanced arresting systems, and cutting-edge radar, every system pushes engineering boundaries. But with new technology comes unprecedented challenges. Over 1,000 workers spent more than a year repairing and upgrading every critical system on this 4,500-sailor, 75-aircraft floating fortress. If you're proud of what our Navy accomplishes every single day, type "proud" in the comments below. Today, we're diving deep into exactly what happened, why this repair was so critical, and what it means for America's naval dominance. The power of the USS Gerald R. Ford. Let's start with understanding exactly what makes the USS Gerald R. Ford such an important asset. This isn't just the Navy's newest carrier, it's the most technologically advanced warship ever constructed. At over 1,100 feet long and weighing 100,000 tons when fully loaded, the Ford is an absolute giant. But size alone doesn't tell the full story. The Ford-class carriers can generate 3 times more electrical power than the older Nimitz-class carriers. This massive power output isn't just for show. It allows the ship to operate electromagnetic aircraft launch systems instead of old steam catapults. These new systems can launch aircraft more smoothly, more frequently, and with far greater precision. Pilots experience less stress on their bodies, and the aircraft themselves suffer less wear and tear. The ship can launch up to 270 sorties per day. That's 33% more than previous carriers. In combat, that increased capacity could be the difference between victory and defeat. More flights mean more strike missions, more reconnaissance, more air superiority patrols. The Ford gives commanders operational flexibility that enemies simply cannot match. But here's something most people don't realize. Despite being significantly more capable, the Ford requires 600 fewer crew members than a Nimitz-class carrier. Advanced automation handles tasks that previously required dozens of sailors. This doesn't just save money on personnel costs, it means less demand on berthing, food supply, and life support systems. Every detail has been optimized for maximum efficiency. The ship also features the AN/SPY 3 multifunction radar system and the AN/SPY 4-volume search radar, creating what's called a dual-band radar. This technology can simultaneously track hundreds of targets while guiding missiles and coordinating air traffic. No enemy can approach undetected when the Ford is on patrol. Why the Ford needed emergency repairs. So what went wrong? Why did this marvel of modern engineering need such extensive repairs so early in its operational life? The problems began during post-delivery sea trials in early 2018. The Ford was out at sea conducting critical tests when suddenly alarms started going off in the engineering spaces. One of the main thrust bearings, a massive component that transfers power from the nuclear reactors to the propeller shafts, had failed. This wasn't a minor issue. If left unchecked, the bearing failure could have caused catastrophic damage to the entire propulsion system. The main thrust bearing is one of 4 that handles the incredible forces generated by the ship's nuclear power plant. Each bearing must withstand tremendous heat, pressure, and rotational forces. When one fails, the entire shaft line is compromised. The Ford had to immediately shut down affected systems and carefully return to port using reduced power. Investigations revealed that the failure was caused by machining errors during the manufacturing process. A company called GE had produced the defective bearing, and those manufacturing mistakes created weaknesses that couldn't withstand operational stresses. This was a serious problem because thrust bearings aren't simple parts you can swap out quickly. Huntington Ingalls Industries, the shipyard that built the Ford, received the contract to repair the faulty equipment. The Navy advanced funds immediately because time was critical. America needed this carrier operational. The repair process required placing the entire ship into dry dock, one of the most complex and expensive procedures in naval maintenance. Here's something that makes this even more critical. At the time of the Ford's problems, the Navy's carrier fleet was already stretched thin. With commitments in the Mediterranean, the Persian Gulf, and the Western Pacific, losing a carrier for repairs created significant operational challenges. But the Navy had no choice. Better to fix the problem correctly now than risk a catastrophic failure during combat operations. The dry dock process. Moving a 100,000-ton aircraft carrier into dry dock is an engineering marvel all by itself. You can't just drive this ship into a garage. The entire process requires precision planning, specialized equipment, and incredible skill. First, the ship must be carefully positioned above the dry dock while it's still filled with water. Multiple tugboats, sometimes 6 or more, maneuver the massive vessel into exact alignment. We're talking about positioning accuracy measured in inches. If the ship isn't perfectly aligned, it could damage the dry dock or the ship itself during the draining process. Once positioned, workers secure the ship using massive wooden blocks and support structures. These supports must be placed at precisely engineered points along the hull to distribute the ship's enormous weight evenly. Getting this wrong could cause structural damage worth hundreds of millions of dollars. Then comes the draining. Over 100 million gallons of water slowly empty from the dry dock. As the water level drops, the Ford gradually settles onto the support blocks. This process takes hours and requires constant monitoring. Engineers watch for any signs of stress, any unexpected settling, any indication that something isn't right. When the dock is finally dry, workers can access parts of the ship that are normally underwater. The propeller shafts, the rudders, the hull itself, everything becomes accessible for inspection and repair. Teams of technicians immediately begin their work, knowing that every day in dry dock costs enormous amounts of money. For the Ford's thrust-bearing repair, specialists had to carefully remove the damaged bearing, install the replacement, and then conduct extensive testing to ensure everything was perfectly aligned. Even the smallest misalignment could cause premature wear or another failure. The tolerance levels are incredibly tight. We're talking about measurements in thousandths of an inch. Before we continue with what happened next, please take just a second to hit that like button and subscribe to our channel. Over 98% of viewers watch our videos without subscribing. It costs you nothing but helps us tremendously in continuing to bring you this kind of detailed military content. Thanks for your support. Meanwhile, the Navy took advantage of having the Ford in dry dock to conduct other maintenance and upgrades. When you've got a carrier out of service anyway, it makes sense to address other issues and install improvements. Teams worked around the clock, performing hull inspections, servicing underwater systems, and upgrading various components. The rolling out process. After 15 months of intensive work, the moment finally arrived. The USS Gerald R. Ford was ready to leave dry dock, but getting this ship back into the water is just as complex as the process of dry docking it. The rolling out process begins with the most critical step, flooding the dry dock. Massive pumps reverse their flow, and water from the James River starts filling the enormous dock. But this isn't done quickly. The flooding happens gradually over several days. Why? Because the forces involved are tremendous. Water rushing in too fast could damage support structures or create dangerous currents around the ship. As the water level rises, the Ford slowly begins to float. Engineers monitor the ship constantly, watching for any unexpected movement or settling. The ship must lift evenly off its support blocks. If one section lifts before another, it could cause structural stress. The entire process is carefully choreographed and monitored from multiple positions. Once the water level matches the surrounding river, the massive caisson, essentially a huge watertight door that seals the dry dock, is removed. This opens the dry dock to the waterway outside, but the Ford still can't just sail out. The ship must first be inspected, systems must be tested, and everything must be verified as ready for movement. Then come the tugboats again. These powerful vessels carefully pull and push the carrier, maneuvering it out of the dry dock and into the main channel. Despite their power, tugboats move the Ford incredibly slowly. We're not talking about miles per hour, more like feet per minute. Every movement is controlled and deliberate. Watching this process in person is absolutely breathtaking. A ship this size seems almost impossible. It defies common sense that something so massive can float. Yet there it is, slowly emerging from the dry dock, ready to resume its mission of defending American interests around the world. The crews manning the tugs are among the most skilled mariners in the world. They understand currents, they know how the Ford will respond to every nudge, and they work together with perfect coordination. One mistake could damage the ship or the dock, potentially causing hundreds of millions of dollars in damage. Once clear of the dry dock, the Ford moves to a pier for the next phase: systems testing and certification. Just because the ship is floating again doesn't mean it's ready for operations. Every system must be tested, every repair must be verified, and the crew must complete extensive training and drills. Testing and certification. After leaving dry dock, the real work begins. The Ford must undergo rigorous testing before the Navy will certify it ready for deployment. These aren't simple tests. They're comprehensive evaluations of every critical system under realistic conditions. The propulsion system receives particular attention. After all, the thrust-bearing failure is what brought the ship to dry dock in the first place. Engineers conduct tests at various power levels, monitoring temperatures, vibrations, and performance metrics. The bearings must prove they can handle full operational loads without any indication of problems. The ship conducts what's called fast cruise exercises while still pierced. During fast cruise, the crew operates the ship as if it were at sea, but the ship remains tied to the dock. This allows them to test communications, damage control procedures, combat systems, and every other operational capability in a controlled environment. If problems arise, they're easier to fix while the ship is still in port. Next comes the sea trials. The Ford heads out to sea for extended periods, conducting increasingly complex evolutions. The ship runs at flank speed, its maximum velocity. It makes tight turns. It stops and starts. Every maneuver tests the propulsion system and the repairs that were made. Navy officials and Huntington Ingalls representatives monitor everything closely, but propulsion isn't the only focus. The electromagnetic aircraft launch system must be tested extensively. Dead load testing involves launching sleds that simulate the weight of various aircraft. These sleds are shot off the deck repeatedly, stressing the system under realistic conditions. Only after dozens of successful launches can the system be certified ready for actual aircraft operations. The advanced arresting gear receives similar scrutiny. This system must stop aircraft weighing up to 50,000 pounds from landing speed to a complete halt in just a few hundred feet. The forces involved are enormous, and the system must work perfectly every time. There's no room for error when pilots' lives are on the line. The radar systems, weapon systems, and communication systems all undergo their own testing protocols. The Ford must prove it can detect threats, engage enemies, coordinate with other ships and aircraft, and maintain communications under all conditions, including electronic warfare scenarios where enemies attempt to jam or disrupt signals. Throughout all this testing, the crew gains proficiency with their ship. They learn its capabilities and its quirks. They practice responding to emergencies, conducting repairs, and maintaining combat readiness. A carrier is only as effective as its crew, and that crew must be expertly trained. Strategic importance. The successful repair and return of the USS Gerald R. Ford carries enormous strategic significance. Aircraft carriers remain the most powerful symbols of American military might and our ability to project force anywhere in the world. When a carrier is operational, it provides options that no other military asset can match. A single carrier strike group can influence events across hundreds of thousands of square miles. The presence of a carrier changes calculations for potential adversaries. Nations think twice before taking aggressive actions when an American supercarrier is nearby. This is what military strategists call deterrence, preventing conflicts through strength. The Ford's advanced capabilities make it even more valuable than previous carriers. Its ability to launch more sorties means it can sustain combat operations longer without support. Its reduced crew requirements mean lower operational costs. Its improved reliability, once these early issues are resolved, means more time at sea and less time in maintenance. Consider the global situation America faces today. China is rapidly expanding its navy and asserting claims over disputed waters. Russia continues to challenge American interests in multiple regions. Iran regularly threatens international shipping lanes. North Korea remains unpredictable and dangerous. In this environment, carrier presence becomes absolutely critical. The Navy plans to eventually field a fleet of 10 Ford-class carriers, though that will take decades to accomplish. Each new carrier replaces an aging Nimitz-class ship. This transition ensures America maintains carrier dominance even as our Cold War-era ships reach the end of their service lives. But the Ford serves another crucial purpose. It's the testbed for all the new technologies that future carriers will incorporate. Every lesson learned, every problem solved, every improvement made on the Ford makes the next ships better, cheaper, and more reliable. The Navy calls this the learning curve, and it's why the first ship in any new class always faces the most challenges. Critics sometimes question the cost of these enormous vessels. $13 billion is certainly a staggering sum. But consider what you get for that investment. A mobile military air base that can remain on station for months, project power across thousands of miles, and operate independently without relying on potentially unreliable foreign bases. No other military asset provides such flexibility and capability. Allied nations also take comfort in American carrier presence. Our friends and partners know that when a U.S. carrier is nearby, they have powerful support. This strengthens alliances, promotes stability, and reinforces the international order that has generally prevented major conflicts since World War II. The human element. Behind all the impressive technology and staggering statistics are thousands of dedicated Americans who make this ship work. The sailors who crew the Ford, the shipyard workers who repaired it, and the engineers who designed it all deserve recognition for their exceptional skill and dedication. Shipyard workers spent over 800,000 man-hours on the thrust-bearing repairs alone. Think about that. These skilled craftsmen worked in difficult conditions, often in tight spaces, always aware that their work directly impacts national security. They took pride in every weld, every measurement, every test. Their professionalism ensured the repairs were done right. The Ford's crew maintained their proficiency throughout the repair period, even though their ship was in dry dock. They conducted training, studied procedures, and prepared for the day when they could take their ship back to sea. Their dedication never wavered. Navy leadership also deserves credit for making difficult decisions. Pulling a carrier from service for repairs creates operational gaps and costs enormous sums. But leadership recognized that cutting corners would only create worse problems later. They made the right call, even though it wasn't easy. This entire episode demonstrates something important about American military capabilities. Yes, we face challenges. New technologies sometimes have problems, but we have the industrial capacity, technical expertise, and financial resources to solve those problems. We learn, we adapt, and we come back stronger. The USS Gerald R. Ford's return to service represents more than just one ship becoming operational again. It represents American determination, American ingenuity, and American commitment to maintaining military superiority. It shows our allies that they can count on us and warns our adversaries that America's Navy remains the world's finest. As the Ford prepares for deployment, she carries with her the hopes and confidence of the entire nation. This magnificent vessel and her dedicated crew will sail the world's oceans, protecting American interests and promoting peace through strength. Outrow. The story of the USS Gerald R. Ford's repair and return to service showcases the best of American military capability. From the skilled shipyard workers who executed complex repairs to the Navy personnel who never stopped training, everyone involved demonstrated exceptional professionalism. This $13 billion supercarrier is now ready to resume its crucial mission. The repairs are complete, the testing is done, and the Ford is prepared to dominate the seas for decades to come. If you found this deep dive valuable, please hit that like button and subscribe for more detailed military content. Your support helps us continue bringing you these stories. The USS Gerald R. Ford is back, and that's very good news for America and our allies around the world.